Hi everyone, my name is Manan Soni and this is my submission for the June internship at the Sparks Foundation. Alright, so my domain is computer vision and Internet of Things, and the topic that I have chosen is Task 1 object detection. And yeah, so this is the project. As you can see, there are quite a lot of files here. First off, there is resize.py. It is an extra file that I have made just to resize all the pictures that I have here. There are nearly 16 images to make them a little uniform and to make their display a little easier to see. And secondly, there is the main script, the object detection.py. Also, in this project, we are going to be using a pre-trained model by the name of MobileNet SSD, and these two files are of that. The proto.txt file here describes the structure of the neural net, and the cafe model, it contains the weightage of the neural net layers. Also, the photos directory here, it has 16 images that we will be using to show this project. Alright, so beginning, let's take it from the top. From these are all the required packages for this program. There are 4 packages: imutils, numpy, cv2, and rparks. Imutils is a utility package, and it contains some helpful functions like list images. We could use OS instead here, but I've chosen to use imutils.paths. Secondly, everyone knows numpy. It's a way to comment. Now also we have cv2. cv2 is a package that contains a lot of pre-written code for image processing and is quite a popular library. And lastly, we have here argparse. This is a library which allows us to easily parse command line arguments. Okay, now we move on to constructing the command line argument parser. Here we have made made the command line argument parser to take in four arguments, 3 of which are required and one is not required, it is optional. The 4 arguments are images. Here we need to enter the path to the images, for example the directory photos. Here we have the model structure. Here we need the proto.txt file, this file. Then we have the model weights, where we need the cafe model file, this file. And then we have the minimum confidence. So default value for minimum confidence is 0.1, but if we run this program with 0.1 confidence, then it will return a lot of objects, even if it is wrong. With the minimum chance, it will return them. So we will actually be using it with a confidence of 0.5 so that it gives us better results. These are the classes of objects that this neural network can detect. There are 20 objects: background, aeroplane, bicycle, board, etc. This is a list of colors which is randomly generated and is equal to the size of the classes list. This is just to make sure that the bounding box of every object is of a different color, of every class of objects is of a different color. Now here we are loading the model using the model structure and model weights. Here we are loading all the images using the list images function and the cv2 library and its function imread to read all the images. Right. Now this is the main part of this program. We are looping over all the images, and for every image, first we are going to be extracting the height and the width of the image using image.shape:2. Now we are using :2 because every image is made up of 3 dimensions: the height, the width, and the channels. Most images have 3 channels, the red, green, and blue primary colors. But because we only need the height and the width, we are using it with :2 so that we only extract the first 2 dimensions. Okay. Now here we are going to be converting the image to a blob of size 300 by 300. We are using the size 300 by 300 because the pre-trained model takes in an input of an image of 300 by 300. Next, we are passing the blob as the input to the neural net, and in return, when we pass it through the neural net, we get a detections list. Now, detection is a four-dimensional list, and it has all the values with the possible confidence levels, the ID of the class that it thinks exists, and the position of the detected object inside the image. So every detection has like 7 values. The first value is 0 by default. The second value corresponds to ID. If ID equals 0, then it is a background. If ID equals 1, it is an aeroplane. If ID equals 2, it is bicycle, and so on. The third number refers to the confidence level. For instance, if the confidence level is 73%, then it will be a float of 0.73. And the last four values correspond to the position of the edges of the box. The the edge points of the box. Alright, so first we have the ID, which corresponds to the first value. Then we have the box, which corresponds to all the value between 3 to 7. Yeah, and the confidence is equal to the second value here. Alright, so here we are passing a condition that if the confidence is more than the minimum confidence as specified in the command line arguments, only then this part runs, otherwise it ignores the detected object. Here we get the starting x, y and ending x, y coordinates so that we can extract the box. Now here we are printing the box on the image using cv2.rectangle, a function provided to us by cv2 library, and we are also going to be putting the text and its confidence level. Text is the class of object identified and the confidence level that the neural net thinks it has. Alright, so now let's just run this program and see how it what it looks like. Alright, so first let's see what values we have passed here. So as you can see, we have specified double dash image photos, which means the photos directory, which has all these 16 images. Then we have the model weights corresponding to the cafe model file. We have proto.txt file, which is here, and finally we have the minimum confidence level, which we have passed as 0.5. So the first image here is of an aeroplane, and as you can see, the neural net has accurately detected the aeroplane with 95% confidence. Here we have a board with 99% confidence, a bus with 99% confidence. Here you can see that the bus is not so accurate because there are a lot of people here, but still the model has predicted it accurately. And also there is a person here which the model sees with 62% confidence, so that is also being highlighted. Now a horse with 98% confidence, another horse with 92% confidence, and one with 53% confidence. Because I think it's a little further behind and we can only see half of it. Car, another car, because the image is very blurry and taken from very far away, that's why the confidence is low. But as you can see, the neural net is quite accurate here. Here there are 3 people, a chair, a couple of bottles, another car, another 3 cars actually. As you can see that we cannot exactly read the third car and what his confidence level is, but if we see the command line, if we see the terminal, and so we can see that it is also printing all of the objects that it has detected with their confidence levels. So we can see that the third car was detected with 50.71% confidence level. Here we can see potted plants 1, 2 and 3. The third one again is not exactly visible there, legible, but we can see that it had a confidence of 53.04%. Car with 100% confidence, a chair, another chair, and a sofa. And now here we have another chair, chair, and a dining table. And lastly, we have a train with 100% confidence. That's it, and I hope you like my project. If you do like and share and comment. And thank you everyone for watching it completely.